All right. Whole different circuit, whole different hookup, different wave, different strategy. These are diodes on the leads that come to the transformer, alternating current. Diodes all connect, so it's direct current because it's going through diodes. Direct current goes in from the transformer leads in to my multimeter, amperage on direct current out of the multimeter back to the power supply. Okay, I have a diode on the input, so this amperage can't get back to the supply. It has to go back into the circuit. For now, that's what we have. Okay, I have a 1 ohm resistor as the load on a bridge rectifier, so it's direct current coming out to a 1 ohm resistor. Now let's unhook the load. Load is unhooked. We have 0 amperage on the load because it's unhooked. Coming from these diodes back to the positive of the supply, we have 0 current, which goes to the positive of the supply because it's feeding direct current amperage back to the positive source from which it came. So we're going to pull a load. 1 ohm resistor is now powered, and it's pulling 260 milliamps direct current. Now we're sending back to the positive, back to the source from where it came, 116 milliamps. 260 we're pulling, and when we pull the load, some of this amperage, an average percent of it, goes back to the positive from which it came. Now, I'm not looking at input versus output, so I don't want to hear comments about, oh, you're measuring wrong. You need to look at the input versus output. I'm not measuring that. I'm showing that you could pull a load. You could pull a load from alternating current, and a portion of that came from the battery, I don't know how much yet, can be returned to the battery or to the circuit. Pulling a load, and it starts to push amperage back into the positive instead of the negative like usual. Now, there's other configurations with the electromagnets. Now I have 8 phases here, and I'm only tapping one with an electromagnet, with a regular doorbell transformer, practically a 110 to 12 volt hooked up on a big side, and we're looking at the fine coils. So we're stepping it up heavy. If it was a 1-to-1 transformer, the readings would be different because the voltage wouldn't be so high. So I think this amperage would go up substantially. I don't know. But anyway, this isn't ideal. It's just a test to see if it's doing what I want it to do, and it is. I'm not pulling a load, and it's sending nothing back to the positive. When I pull a load, it starts to return the current to the positive. Now I have inefficiencies. First of all, a bunch of diodes are dropping my voltage. That's hurting me a little bit. I'm only using 4 phases right now on my resistor rig, so it's going through resistance, and I'm using 4 phases only. So my sine wave is a modified chop wave, which is hurting me. It's not a nice, smooth, good wave, so those chops are hurting me. And I don't think this transformer is what you want to use for rotating magnetic fields. But as you can see, the effect is starting to manifest once again. And this is the best results yet with this new scheme. 0 amps going back to the battery. Now I don't want to, again, last time I posted, of course you get comments, oh, you're measuring all wrong. This is direct current measuring going back into a direct current supply, okay, with diodes there, so it's only direct current going through this meter. And it goes from a positive wire, positive, to the common, and the common goes back to the input, which is direct current. I'm measuring correct. I don't want to hear input versus output. I'm not looking at that. I'm looking if it's possible to power a load and return some of the current that it took to power this load back to the source. Get it?